So this is Calc 30. This is section 1.4, question number 10. And we're talking about formulas for the instantaneous rate of change. So when it says find the slope of the tangent, that's the instantaneous rate of change at that point for this parabola, at the point whose x-coordinate is a. So what this is doing is this is helping you find an expression for the instantaneous rate of change. An expression that will, all you have to do is plug in an x value for any x value you want. You just plug it into the expression and you can quickly find the rate of change. You don't have to start from scratch all the time. So how you do that is use one of your formulas. It doesn't really matter which one. I'm going to use the h approaches 0 one. And as you know, that's f of a plus h minus f of what? A all over h, right? So instead of putting in a number in for a, I'm just going to leave a in for a. So it looks something like this. Here's the function. So I literally have a plus h, so 3 times a plus h squared, plus 2 times a plus h, minus 3a squared plus 2a. Is that good? Yeah. Make sure you include your brackets there. Don't forget those. The limit as h approaches 0, so if we expand this out, we get, what is that going to be? 3 times a squared plus 2ah plus h squared plus 2a plus 2h minus 3a squared minus 2a all over h. Good with me so far? Does that look good? Yeah, you're good. Do everything right? Okay, so now I've got 3a squared and minus 3a squared. Those are gone. I've got 6ah, no other ah's. I've got 3h squareds, right? 3h squareds. And I've got, what else? I've got 2a, oh, the a's are gone. And I've got plus 2h. So, girls, watch here. This is, you guys asked about this. This is important. Okay, so you got it now? Well, and here's the actual answer from the solutions all on there as well as I finish this up. But as h approaches 0, now we can actually put 0 in for all the h's here, can't we? Or no, we can't. Sorry, we got to factor out 6a plus 3h plus 2 all over h. Those h's are gone. I can actually plug h in now, so I get 6a plus 2 because the 3, let me show all my work, plus 3 times 0 plus 2, that gives me 6a plus 2. And that is the limit as h approaches 0. That is the expression for the slope of the tangent line. That's the expression, yes. Okay, so the question was asked, can you use Formula 1 for this? And totally you can. It's a little bit trickier. That's why I like Formula 2 usually better. But here's what it looks like. You set up Formula 1, and there's f of x, there's f of a. What I did here was I factored by grouping. So I took out factors from these terms here, and then factors from those terms there. There's a difference of squares here. You can factor that further. And then you get x minus a as a common factor on the top and as a factor on the bottom. When x equals a, or when x approaches a, that means the x values here become a values. So that's 3 times 2a plus 2, or 6a plus 2. So you can use both formulas there. In this case, Formula 2 is easier. And I would argue that most cases Formula 2 is easier because you're expanding and gathering like terms and factoring one h out. Formula 1 is you're expanding, gathering like terms, factoring a binomial out, which can get trickier than just factoring a single term out.